Okay, let's solve this equation. So I'm going to write on this side so I can start working out 2x plus 4 over 2 minus 3x over x minus 4 equal x. So what do we have? We have equation that has fractions. So what common denominator we have? 2. We have, with denominator, not common denominator, just denominator. We have denominator 2 and we have denominator x minus 4. For x, denominator is 1. So we don't have anything in common in this among these denominators. In this case, what we're going to do, take and multiply them by each other. So it's going to be twice x minus 4. Well, makes no sense to put times 1, right? So the first fraction has denominator 2. To get this common one, I have to multiply by x minus 4. Second one, x minus 4, I have to multiply by 2, right? Because I have only x minus 4. So I have to multiply by 2 to get the common denominator, which means here also I'm multiplying by 2. And for x, I have to multiply by entire denominator, which is going to be twice. I overwrote this 1 because 1 doesn't do anything. X minus 4, and same way here, twice x minus 4. Okay, so let's see, x minus 4 times 2, x minus 4 times 2, twice x minus 4. All right, so we drop that and we get. So I can clean this, we don't need this anymore. And so what we're gonna do? We're gonna get x minus 4, 2x plus 4, minus 3x times 2, it's gonna be 6x is equal to x minus 4. Okay, let's multiply. X times 2x, it's gonna be 2x squared. X times 4, it's gonna be plus 4x. Negative 4 times 2x, it's gonna be negative 8x. Negative 4 times 4, it's gonna be negative 16. Minus 6x. It's equal 2x squared minus 8x. So we multiply 2x squared minus 8x. Okay, so let's see. I'm going to move 2x squared on this side of the equal sign and negative 8x on this side of equal sign. So which means it's going to flip the sign, yes? So we have 2x squared plus 4x minus 8x minus 16 minus 6x minus 2x squared plus 8x. So 2x squared is positive. I'm moving on this side, I'm getting negative. Negative 8x is negative. I'm moving on this side, becomes positive. And you know what? This negative 16, let me move this negative 16 on the other side because it's available term. And that's going to be equal positive 16. So I will take it from here. Clean this negative 16. Okay. All right. What do we have? So first of all, this 2x squared will be cancelled with this negative 2x squared. Negative 8x will be cancelled with positive 8x. Next, so like terms, 4x minus 6x, it's gonna be negative 2x, right? Equals 16. And divide by negative 2 here, divide by negative 2 here. X is equal negative 8. 16 over negative 8. Okay. Next problem. What do we have? Absolute value 2x minus 3 is equal 6. So, what does this mean? That means that we are going to put that, okay, let me write down here, 2x minus 3 is equal 20, equal 6, okay. All right, so when we take off absolute value, that means 2x minus 3 is going to be equal plus minus 6. Okay, because it's going to be plus minus 6. So absolute value of a, for example, if you have absolute value of a, it can be plus or minus a. All right. So from here, what do we have? 2x is equal plus minus 6 plus 3, because I'm moving this 3 here. Okay, so let's separate. 2x is equal positive 6 plus 3. 2x is equal negative 6 plus 3. So we get 2x is equal 9. And we have 2x is equal negative 3. So from here, we divide by 2 here, divide by 2. This one also we divide, and I am getting x is equal 9 over 2, and x is equal negative 3 over 2. And the answer is going to be 9 over 2, comma, negative 3 over 2. Next question. All right, question number 3. Absolute value 8 minus 4x equal 3. So, if we open absolute value, we are going to get 8 minus 4x is going to be equal plus minus 3, right? Okay, so which means, let me write down 8 minus 4x is equal positive 3. 8 minus 4x is equal negative 3. So from here, what do we have? This negative 4x, I am moving on this side, which will be positive. 8 minus 3 is equal positive 4x, and this 3 moving on this side will become negative, because it was positive, will become negative. Negative 4x was negative, become positive. And same thing here, 8 plus 3, it's going to be equal positive 4x. Okay, 5 is equal 4x. Here we have 11 equal 4x, and we need to x, not 4x, therefore we are going to divide by 4. By 4 here, this one also. I'm solving two equations at the same time. And we are getting, this is gone here, this is gone here, and we are getting x is equal 5 over 4, and x is equal 11 over 4. Okay, moving to question number 4. Okay, moving to question number 4. So y is equal 2 over x minus 8. In this case, we need to figure out if this relation is a function or not. So, how do we understand where we have function, where we don't have function? When x has only one y, let me see, I'm going to explain to you by graphing. Okay, if I have graph like this, parabola, so let's take any x, and I'm providing vertical line. And vertical line is crossing the graph in one point, which means we have one x and we have one y. So in that case, we have function, okay? Because if every x has to have only one y, so this will be function. Now let me bring example where the graph or the relation is not function. Let me turn around this, turn by 90 degrees, this parabola. Okay, I'm taking again here x. And if I provide that line, let's this one also make dashes, this okay, this is not a good one. Okay, 1 second, and this is gonna go as a dashes. Okay, so 1 point. Now in this case we have, this is x, but it will crossing two y's. This is y1 and this is y2, which means in this point is x and y1. In this point we will have x and y2. This is comma, this is not 1. Okay, so when x has more than one y's, then it's not a function. Let's see what we have here. Y is equal 2 over x minus 8. So in this case, for every y, every x will be only one y here. Because if I take any value of, let's say, let me take value here, 3. 3 minus 8 will be negative 5, and y will be 2 over negative 5, right? Let me take another value, let's say 9. 9 minus 8 is 1, y will be equal to, as you can see, for every x, we have 1 y. When it would be not function. So in this case, first of all, we have function. Now let me bring you example in what case we wouldn't have function. If I would have, so if I take y, x is equal y squared, it's going to be this graph. This graph with this orange color is x is equal y squared. So on the graph we see that it's not a function because every x has two y's, right? Now let's look at algebraically. Why is that? Okay, so let's assume my x is equal 4. Okay, if my x is equal 4, what do we get? 4 is equal y squared, right? So in this case, if I take a square root from both of them, I will get plus minus 2, because square root 4 is a plus minus 2. Why? Because negative 2 squared 4, positive 2 squared is 4. And this is going to be equal also plus minus y, right? So from here, what we can say, positive 2 is equal plus minus y, and negative 2 is equal plus minus y. So every 2, which is value of x, has 2 y's. Here is the 1x and has 2 y. So, which means coordinate for this will be 2 positive y and then 2 negative y. The same way is here, negative 2 y and then negative 2 is negative y. So the same x has 2 y's. Okay, therefore it's not a function. Okay, moving to question number 5. Y is equal x to power 7. Okay, how we can prove this? Let's say x is equal 1. I'm getting y is equal 1. Yes? If I take x is equal negative 1, y is equal negative 1, because negative 1 to power 7 is going to be negative 1. What else I can do? Let me take one more. Take x is equal 2. So x is equal 2. Then y is equal to 2 power 7, right? Whatever value it is, it still get one answer. Therefore, we are going to say that this is a function. Okay, now let's talk about domain. What is domain? Domain is a values, all possible values of x. Okay, all possible values of x, that function can exist. All right, is there any restriction that x cannot be here? Well, I don't see it. All I see, domain, or which is x, value of x can be anything. So entire line from negative infinity to positive infinity. Therefore, I'm going to write down negative infinity, comma, positive infinity. And I put parentheses because parentheses shows that the end value is not included. And for us, end value here, positive infinity and negative infinity. Since these infinities do not have end, therefore we use it parentheses. And accordingly, range. So let me see, domain is our value of x, and range is possible value of y. So usually, because y depends on x, therefore if domain can be any value, then ranges also can be any value. I don't see any limitation. So also going to be negative infinity to positive infinity. Let me for a second go back and identify here domain also for this one. So in this case, y is equal 2 over x minus 8. So is there any limitation what x cannot be? Yes, x minus 8 cannot be equal 0, right? So this is domain, which is value of x, cannot be equal 0 because we cannot divide by 0. And from here, x cannot be equal positive 8. So x can be anything but positive 8. So therefore we are going to write down from negative infinity to 8. Since 8 cannot be included, we put parentheses, and from 8 to positive infinity. If I draw on the graph, so this is my 8, let's say, and it's going to be empty circle. So it's going to come from negative infinity to 8, and we put parentheses, which means parentheses mean 8 is not included, and from 8 to positive infinity. And the range, for the range, since we don't have the x plus 3, x minus 4, any term attached to y, then all we can do, test for value of x. Let me move this a little bit down because I didn't expect I will go back. There we go. Okay, so for a range, which is value of y, we are testing for 0. So 0 is equal to over x minus 8, which means 0 times x minus 8 is equal to. Why? Where from I got this? So I'm bringing to common denominator x minus 8, and here is time x minus 8, right? So I can drop this and get 0 times x minus 8 equals 0. So 0 times any term, it's going to give you 0 equal to, which cannot happen. This is why range is going to be any value but 0. So from here, negative infinity to 0 and 0 to positive infinity. And that will be your range. Okay? So, but we did solve 5 also. Moving to number 7. Question number, 6. Let's solve question number 6. So y is equal 7x minus 4. Okay, is this a function? Let's see. We don't have x any degree. We don't have y any degree. Both of them are degree 1. Yes? When both of them degree 1, then it's definitely function. Because 1 meaning linear equation. Linear equation has linear graph, right? And on linear graph, if you provide this vertical line, just like we tested here, providing here this, you see this dashes line, providing here to see it's crossing in any point I provide vertical line, it's going to cross only in one position, right? In one point. And every x will have only one y. That's why it's not going to be a problem to right away with degree 1 insist that it is a function. All right? Okay, now let's identify domain. Does x have any limit? No, because we don't have any division. Usually the limit of x is we can observe when we have division, when we have fraction by division by x, when we have x in denominator. Then we have limitation on x because we cannot divide by 0. Okay, so this is for x. It is going to be negative infinity, positive infinity, any value. And for range, accordingly also, it makes no sense to check on anything, because if domain is negative infinity, positive infinity, then range is also negative infinity, positive infinity. Usually you look for restriction on range only if domain also has restriction. Moving to question 7. Y is equal 10 over x minus 1. Okay, we need to find if this is a function or not. Okay, well, you tell me now, looking at the equation, do we have x degree 1? Yes. Do we have y degree 1? Yes. Then you shouldn't have any hesitation that this equation is a function. Next, we need to figure out the domain. Now this is going to be different case because I told you every time when we have division by x, we have to watch out if at the value x denominator will become 0 and prevent it from becoming 0 because we cannot divide by 0. Well, let's see. For our domain, which is our x minus 1 cannot be equal 0, right? The entire denominator. From here, which means x cannot be equal 1. Why? Because when x is equal 1, the denominator becomes 0 and we divide 0 by 0, which we cannot afford. So from here, domain is going to be from negative infinity to 1 and from 1 to positive infinity. But that's all. Range, since our the x has limit, right, which is it cannot be 1, then we're gonna test it also range. Usually, like I said, when you have limitation on x, you definitely, which means the limitation on domain, then you definitely look for limitation on range. But if x is running from negative infinity to positive infinity, then your range is also running from negative infinity to positive infinity because y always depends on x. Okay, we have limitation, cannot be 1, the domain, which means we are looking for limitation on our range also. Since we have only y, we don't have y plus something, y minus something, or whatever. So we are testing only on 0, which means 0 is equal 10 over x minus 1. And for the same calculation on the top, if we bring to common denominator, x minus 1, here also times x minus 1. So and drop denominator, we are getting 0 is equal 10. Okay, let me go slow. 0 times x minus 1 is equal 10, which means 0 is equal 10, right? Okay, which cannot happen, but which means range cannot be 0. Therefore, our range is going to be negative infinity to 0 and 0 positive infinity. All right, question number 8. Here we need to evaluate. So what do we have? F of x is equal negative x squared plus 6x plus 1. We need to find f of negative 3. All right, let's do it, which means we need to, instead of x, we plug negative 3, right? So it's going to be negative, and then x is negative 3 squared plus 6 times negative 3 and plus 1. Okay, negative 3 squared is 9, right? Negative 9 plus the minus 6 times negative 3 is going to be negative 18 and plus 1. Okay, negative 9, negative 18 is negative 27. Negative 27 plus 1, it's going to be negative 26. Yes? Okay. So what do we get for f of negative 3? It's going to be equal negative Oh, 26, I'm sorry. Negative 26. Okay, question number 9. So we have a graph. Let me build this graph. We have such graph. Okay, and then another graph, graphing line. So on this graph, using this graph, we are going to find how much will be the f of negative 1. So when we say f of negative 1, so it's the same as of f of negative f of x, which means x is equal negative 1. Here is my negative 1. I'm going down. Okay, 1 second. So if I go down, it's going to be negative 2, right? Negative 1, my x. Then it's going to be negative 2. Y will be negative 2 on the graph. Okay? All right. Question number 10. Let me graph this one. So this is one. This is another one. And I have 1, 2, 3, 4, 5. And I have here 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. So let me see the points I have. It's coming from here and it's going all the way to here. And then from there, it's coming down, let's say, somewhere here. And from here, it's going up here. Okay. So let's see. We need to find, so let negative 1, negative 3, at the 1, 3, 5, 1, 3, 5. We need to find f of negative 2, how much will be f of, let me see, positive 1, and then f of 0, and f of 6. Let's start. So f of negative 2, this is my negative 2, right? Because it's value of x, so which means y is right 0, right there. Next, f of 1. So where is my 1 on x? Here. I'm going up, and it's coming right on 3, which means f of 1 is going to be equal 3. F of 0, which means when my x is 0, how much is going to be my value? It's going to be all the way 5, correct? Because x is 0 right here, and graph is right here. So when it's 0, it's going to be equal 5. And when my f of 6, when my x is 6, it's right here. So my y is going to be right this point, which is coming here. It's going to be 2.5, right? Okay, that's all. Question number 11. Okay, let's see what we have, what we need to do. We are given graph. We are given graph. Let me draw this graph. Okay. So let's identify on which part interval it's increasing, where it's decreasing, because our goal is going to be figure out on what interval the graph is increasing, what interval graph is decreasing, and where it is constant. So if I go this way, on this piece it's increasing, yes. Next it's decreasing. I'm changing color so you will see it's decreasing. And then again it's increasing, and then from here it's decreasing. Okay, so our limits are going interval is going to be from negative infinity. That's where at the point where color is changing, that's mean from increasing to moving to decreasing, or vice versa, from decreasing to increasing. We need this switching points on the x-axis, not y, only on the x. So here this switching point right here, so my x is going to be here, which is going to be 0. Where else I have switching point? I have switching point here. So my point here is going to be, if this is negative 1, this is positive 1, this is going to be 1.5, right? And switching point we have here, which x value of x is going to be 2.5, I would say. And that's it. So we are using only x value of x on this switching point where it's changing from infinity to infinity. Let me make it even a little bit more interesting. See if I can clean this. Okay, and I can go from here like this and put the arrow here, which will be constant actually, right? From this point is going constant, correct? And this, what point is this? This is where it's switching, and this is this point, which is going to be free. Okay, so let's work this out. Increasing, increasing, decreasing, constant. So it's increasing. This arrow, that means the value of x here on the negative side, right? So it's going to come from negative infinity, and it's coming all the way to here, this point. The value of x for this point is 0. Oh, I might as well put this color, negative infinity, comma, 0. Do we have where else increasing? Yes, green color right here at positive 1.5, comma, and it's come all the way to positive 2.5x. Because the interval we identify, it's on x value, okay? Next, decreasing. It's gonna decrease from 0. It's decreasing all the way to 1.5 on the x. The blue color is changing here, 1.5. And then is decreasing from 2.5 all the way to 3, right? This point, that's a value of 3. Next, constant from the point of 3. It's going towards positive infinity, right? Yes, on the x. There we go. We are done. Okay. Moving to question number 12. Let's move to question number 12. So we need to graph the following equation. F of x is equal x plus 6. Okay, and find the domain and range. So to build a graph, we need only 2 points, right? We can build with method of intercepts and or with the method of slope. So which one we gonna use? Because on MyMathLab, the method of intercept, it doesn't allow to type in the point right away. Why do we need to type in the points of coordinates? Because if you have fraction, let's say 2.3, 2.6, it's going to be difficult to count precisely. But if you don't have it precisely, it will not accept as a correct graph. Therefore, we are going to go with method of slope. So write down y is equal x plus 6, because f of x and y it's the same thing. So let me build the graph of y and build the graph of x. So to draw the graph by slope, we always start with this available term, 6, which is our intercept, y-intercept. So if I go 1, it's on y, obviously. 1, 2, 3, 4, 5, 6. Okay, right here. So I'm starting from here, 6. Now, slope here, it's a coefficient of x, which is 1 over 1 in my case, right? Because there is no other coefficient. Then we take 1 over 1. It has to be in the form of fraction, the slope. So when we have the slope 1 over 1, so the 1 in numerator, it's running vertically. The 1 in denominator, or any number in denominator, running horizontally, rise and run. So first I'm going to go 1 that is in at the numerator, which means go up by 1. You know what? I'm going to show you the trick. So positive 1 by 1 over 1. See, it's not convenient. I have 6. From this point 6, I have to go up by 1 again, and there is no space, and I'm not interested to go up. Squeeze in the other graph. Therefore, what am I going to do? 1 over 1, I can represent as a negative 1 over negative 1, right? It's going to be same 1 over 1. Because negative by negative is going to be positive. Therefore, instead of going up by positive 1 and then right towards positive 1, I'm going down by 1, this one. Okay, because it's the numerator, it's running vertically. So I'm going down by 1. Here I came down by 1. And then I'm going horizontally by 1. Since it's negative 1, therefore, I'm going from here, I'm coming horizontally by 1, right here. So this is my second point. Therefore, my graph is going to look like this. Okay? I will put, whoever needs to watch in details how to build the graph by slope and intercept, I will put the reference to the video. I believe it's in my intermediate math or basic math _K. It should be there. I will point that video and you can go and watch it. But this is how we're gonna build. Okay, next, question number 13. Question number 13. What do we have? 4x minus 4y is equal 16. So what is our goal here? To identify the slope. Okay. How we are going to identify? From this equation like that, we cannot identify the slope. We have to bring to the format y is equal mx plus b, which means from this equation I need to find y. Okay, 4x minus 4y is equal 16. So let's find y. Negative 4y is equal, this 4x I'm flipping over, this equal sign, it will become negative. Remember, every time you flip over equal sign, you change the sign on the opposite. So it will become negative 4x plus 16. Dividing negative 4, negative 4, negative 4. This is gone. This is also negative 4, negative 4. This is 1, this will be 4, right? And we have left y is equal positive x and minus 4. Why minus? Because this negative still survived, right? Okay, y is equal x minus 4. Now, we already have the same format, mx plus b, here also. So coefficient of x, which means in this case we have 1, is gonna be our slope. So for this case, I can write down slope is equal 1. And now we need to draw the graph. So we are going to draw the graph x minus 4. Y is equal x minus 4, this graph. Okay, very easy. So x minus 4. So our y-intercept is negative 4, available term, always. So 1, 2, 3, 4. This is our negative 4. Again, since we have 1, which means it's going to be slope is going to be 1 over 1, right? Okay. So since we have positive 1, this is going to run vertically, this is horizontally. Positive 1, we are coming up, right? Positive 1, and then go horizontally by positive 1 from here. There we go. And that is going to be my next point. First point is your intercept, this available term. Second point is giving you slope. Okay, providing line. And that is my graph. Moving to next problem. Question number 14. So actually I'm going to combine 14, 15, 16 and 17. Okay, let's do it. It's not gonna be difficult. All right. So on question number 15, 16, 17. Wait a minute. How about 14? Let me see 14 also. Okay. 14, 15, 16, and 17. They are related to one only question. Identify slope based on graph. Okay? Therefore, I'm going to show you all versions so you can complete 13, 14, 15, 16, 17. Okay. So, let me explain. This is 14 all the way through 17. Okay? So, we're gonna learn how to identify the graph with negative slope, with positive slope, with slope equals 0, and slope is undefined. Okay? All right, therefore I am preparing 4 graphs. 1, Actually, I can draw by hand to not to waste time. This and this. Not bad, huh? Third one. Not bad at all. Let me make more space so I don't move behind of page. Ah. Well, it's not working, but that's fine. I will make it work. I will leave as the last one, the one that it's gonna be working very well. Okay. So, let's assume I have graph like this. You can see that this graph is increasing, right? It's growing, correct? So, for this graph, slope is always gonna be positive. If you are given slope is positive 8, positive 9, positive 4, you want to look for, as long as it's positive, you want to look for the graph that is running up. Okay, let me use this last one for the graph that is running down. Look, running down, yes? Which means the slope, that the graph that is decreasing, that means the slope is negative. Next, for the graph that is running horizontally, the slope is equal 0. What is slope? Slope is an angle. When you are driving on the hill, that's in life, then you are driving on the hill, up the hill, then your slope is going to be positive. When you are driving down the hill, then your slope is going to be negative. When you are driving on the flat area, on cruise, let's say, driving on the flat road, then your slope is going to be 0. But when the rocket is from NASA, let's say, taking off vertically, what's going to happen? The slope is going to be undefined. Okay? One second, and I will place it. Yeah. And I have color, so it's gonna go. Okay, let me put here. Vertical. So the slope is undefined. Okay? All right. That's all. I'm done. See you in next video.